Alright. Okay. So the difference between linear and angular momentum is that the angular momentum is the body, okay, the fluid is moving in a rotational motion. Jom nak masuk sekejap Okay. Okay. So the motion is in rotational, berpusing lah. So that's why they have angular momentum. Compared to the linear momentum, your motion is a linear motion. So that's why you have the linear momentum. Okay. So that's the big difference lah in angular and linear momentum. So because of that, okay, because of the points of that fluid or whatever is moving in rotational, so you have what we call as angular property lah, angular distance, angular velocity, angular acceleration. So everything is in angular because you moving in a rotational motion. Okay, so you have the angular distance, and if you look at this diagram and this shape, this circle shape, where your point is moving, dia moving in rotational, banyak kan, ada banyak contoh benda yang bergerak secara berputar, it rotates kan. Okay, so this point, okay, is moving along this this shape. Okay, so you have your angular distance denoted by this theta, this one. Okay, and you have your angular velocity, okay, W, okay, and angular acceleration, alpha. Alright, so this is all the property for angular momentum, because it's moving in rotational. So in order to find the angular velocity, don't masuk lagi. So I'm sorry to those yang masuk awal. I keep come back and to allow them. Okay, so you have this property, angular velocity, angular acceleration, and angular distance. If you look from this diagram, so this theta is your angular distance, and because you move like this, bulatan. Okay, and you have your angular velocity, W, and your angular acceleration, alpha. Okay, angular velocity, W, is equal to V. So what is V? So V is the linear velocity. So you have that body is moved in circle kan. So you have your linear velocity kan, yang not moving in rotational. So that linear velocity is your V. Okay, so V, linear velocity, divide by your radius, this is the radius, will give you your angular velocity. Okay, ada lagi yang nak masuk. Okay, so that is how you find your angular velocity, the linear velocity V, this tangent to this point is your linear velocity, divide by radius will give you your angular velocity. Okay, and angular velocity is expressed in RPM, okay, revolution per minute, and because it rotates in a circle, so you have one revolution, 2, 3, how many lah? So it's per minute, okay, and is denoted by n dot. Okay, so that is your angular velocity and angular distance traveled per time. Right? This is why you should come on time. Sorry. Okay, let's go back. Okay. So that's your angular velocity in revolution per minute and denoted by n dot. Okay. How you get, okay, if any one of you curious how you get this equation, V over R, okay, is very easy. So if you look from this diagram, okay, so this distance, this part of distance also is a length, okay, where we call it is L, length, okay. Initially, you know that velocity is angular distance per time can. Angular distance is this distance theta. So angular velocity is equal to angular distance theta over per time, per time. Okay, this is your original equation, and you know that this theta, okay, can be write in the L, this length, okay, this length over radius. This is something that we learned before in secondary school, how to find this, okay. So this theta is actually equal to the length of this part over R, okay. So L over R over T, okay. And if you take out the R outside, so you have 1 over R, okay, L over T, okay. So where this V comes from, okay, the L over T, okay, meter per second, this L is in meter, the length, right, meter per time is velocity again, okay, and this where you get the angular velocity is equal to the velocity over R, okay, L over T ni V and then over R. So that's where you get the angular velocity is equal to the velocity over radius, okay. And to convert revolution per minute and the angular velocity to radian per second, okay, you just multiply by 2 pi over 60 lah, this radian per second, okay. To change meter to second, minute per second, you divide by 60, and to convert the revolution to radian, you times by 2 pi, okay. So that is angular velocity. And angular acceleration sama je macam your acceleration, your rate of change in velocity kan, okay. But in angular acceleration is rate of change of your angular velocity, so it's just mirror of your what we have done in linear momentum, okay. Angular velocity, angular acceleration, your acceleration lah, okay. The angular acceleration is rate of change of angular velocity, and to find that the angular acceleration, the AT over R, the AT linear acceleration over R, okay. Sama macam you find angular velocity, linear velocity over R, angular acceleration, linear acceleration over R. Okay, so that is the what we call as angular momentum. Okay, so dia quite senang juga lah, not too complicated. Okay, angular momentum is equation is used to solve a lot of engineering problems involving the moment of the linear momentum of flow stream and the rotational effect caused by that lah, by them, ada pump ke, turbines ke, fans, all of this application is moving ni kan, in rotational kan. That's why you have that angular momentum, okay. And the angular momentum equation used to solve these engineering problems is also limited to steady flow condition, okay, only steady flow condition. So by definition, okay, the angular momentum is the net torque on the control volume during steady flow is equal to the difference between outgoing and incoming momentum flow rates. To translate this sentence in equation, so this is your equation for angular momentum. Okay, summation of momentum equal to the difference between the outgoing momentum flow rates, okay, R times m dot v minus R times m dot v for for incoming. So the outgoing minus the incoming, so this is your net torque. Okay, so this is your momentum that the equation that you will use, okay, in order to solve any problems regarding angular momentum. Okay, alright, boleh? Okay, we look some of the example, okay, for angular momentum before we do a tutorial on linear momentum. Okay, this underground salah apa aja. Okay, this underground water, and so the water coming from the underground. Okay, this underground water is pumped through a 10 cm diameter pipe. So this is the pipe with 10 cm diameter that consists of a 2 meter long vertical. So this vertical long is 2 meter and 1 meter long horizontal section. Okay, ada 2 meter vertical and 1 meter horizontal, as shown in figure this one. So water discharged through atmospheric air. Okay, the water discharge keluar through the atmospheric air at an average velocity of 3 meter per second. Okay, and the mass of the horizontal pipe, so this is, so dari W lah ke bawah. Okay, the mass of the horizontal pipe section when filled with water is 12 kg per meter length. 12 kg per meter length. Okay, so 12 kg per meter length. So this, in this 1 meter will be 12 kg lah. Okay, 12 kg. Okay, they give you in 12 kg per meter length. Okay, the pipe is anchored on the ground. Okay, kat sini by a concrete base. So ada concrete base to anchor this pipe. Determine the bending moment. Okay, they ask you to find the bending moment acting at the base. Okay, this is your base. They ask you to find the moment. Okay, whether counterclockwise or clockwise, depends on your value after this. Okay, they ask you to find the bending moment acting at the base of the pipe, point A, and the required length of the horizontal section that would make the moment at point A is 0. Okay, so they ask you to find the horizontal section for this moment to make the summation moment to at point A is 0. Okay, so that is the question lah. Okay, question macam panjang. Okay, and I think it's quite long. You need to understand how the question first, then you can do how to solve this question. Okay, this is the property semua lah, the assumption semua. Okay, and the role of the water. Okay, so to solve this question, first you need to draw your FBD lah. Okay, to label all your force on this control volume. Okay, your FBD. So you have your A1 and A2, but this pipe is they say is a summer size, so the size of this pipe is similar, so you expect the you should know that A1 A2 is the same lah, the diameter is the same. And this is your P1 A1 comes in from the bottom. Okay, and you have your moment at this point A, but they said at this point. Okay, and you have your W going down, and they gave you the W, and you have M dot V2 comes up, alright, and you have another W for this pipe as well, the horizontal, the vertical pipe, WA downward. Okay, So that is your FBD, and this is the length for horizontal, the vertical R2 2 meter, and R1 R1 ni is the half of 1 meter lah. This is 1 meter. So you have your half point at your W, and we know W acting at the middle section kan, in the at tengah-tengah lah. So that's why you have R1 is half of your 1 meter. So they give you 1 meter sini, so your W must always acting at the center lah. Okay, that's why you have your R1 is 0.5 meter. Okay. Okay, so this is what it says here. The conservation of mass equation, continuity equation is sama, Q1 or sama dengan Q2. Okay, M1 M.1 equal to M.2, and you have your V1 also equal to V2 because the area of this pipe is constant. Okay, there is no reducing section or increasing section, so the area is constant. So that's why your mass flow rate and velocity is the same. Okay. Next, the mass flow rate and the weight of the horizontal section of the pipe. Okay, first you do for your horizontal section to find the weight and the mass flow rate. Okay, this is the equation. Okay, the mass flow rate, you still need to remember your continuity equation. Mass flow rate rho times Q kan. So this is Q, AVQ, or A times rho times area times velocity to get your mass flow rate. So you have your rho 1000 and you have your area, so they give you the diameter. Okay, pi r squared or pi d squared over 4. Okay, whichever you like to use. Okay, pi r squared or pi d squared over 4 times the V. Okay, they give you the V inside the question equal to 3 meter per second. Okay, times everything, so you get your meter, your m dot with the mass flow rate. Okay, kilogram per second. Right, so that's your m dot, and your W. Okay, the weight for this one. Okay, they give you the weight per meter length kan. The mass is 12 kg per meter. Okay, times 1 meter to get only the mass. Okay, 12 times 9.81. Okay, G, your G lah, constant. So this will give you the weight. Okay, W. So this component equal to 117.7 Newton. Okay, so you have your m dot and you have your W. Okay, to determine the moment acting on the pipe at point A, kat sini. So this is your reference point, where if you remember we learn before, the hinge lah, macam hinge dia, kat mana point moment tu acting kan. So you have one fixed point. Okay, and this question they ask you to find the moment acting on point A. So this is your point. Okay, so we need to take the moment of all forces and momentum flows about this point lah, about point A. Okay, you have MA and you have W. Okay, and you have to sum of this to get your moment. Okay, and this is a steady flow problem, and all forces and momentum flows are in the same plane. Therefore, the angular momentum equation, the angular momentum equation in this case is expressed as, the summation of moment yang keluar, R times m dot times V, tolak yang masuk, R times m dot times V. Okay, this is your equation where we learn at the beginning. Okay, so remember out time minus in. Okay, where R is the average moment arm, jarak moment tu bertindak. Force tu kan moment F times R kan. Okay, so your R is your distance lah, your distance in meter. V is your average speed, they give you in this question 3, and m dot, you find your m dot here. Okay, so you can find this summation of moment using this equation, and you have all value lah. Okay, so you can rearrange your equation, to find that. Okay, next, the free body diagram of the L shape is given in 6.36, noting that the moments of all forces and momentum flows passing through point A are 0. The only force that yields a moment about point A is the weight W, ini, okay, of the horizontal part. So this is horizontal part. So this will create a moment lah, ke apa, clockwise. Okay, this is your point A. So this weight will exert a moment clockwise, macam ni kan. So this is the distance, okay, the arc for this W, okay, and this W will have a moment acting clockwise, okay, and the only momentum flow that yields a moment is the outlet stream. Both are negative since both moments are in the clockwise direction. Okay, so this is clockwise direction, so it's negative. Your you take your moment at point A, counterclockwise is positive, so that's why all the clockwise is negative. Then the angular momentum equation about point A, okay, sini becomes, okay, MA minus R1 times W, and it's clockwise, is equal to R2 times yang ni, R2 panjang ni, time this M dot V2. So this will also create another moment. So they have M dot V2, and the distance is the arm is this distance. Okay, about point A kan. Okay, times 2 lah. So this R2 is 2. Okay, this length times the M dot V2 have another term for your moment. Okay, so that's why you have this equation. Okay, and when you rearrange back, okay, you bring this one to the other side. Okay, so you will have your moment at point A equal to R1 times W minus R2 times M dot times V2. So you have your R1, you have your R2. Okay, R1 is equal to this 0.5 for W, and R2 is 2 meter for M dot V2. Okay, so 0.5 times W. So you already calculate your W earlier. This one 117.7. Okay, so they just use 118. Okay, minus R2 is 2, panjang yang vertical tu, sorry, this one 2. Okay, times M dot. So you find your M dot earlier as well. This one 23.56. Okay, times V2. V2 is 3, given in the question. So this will give you the moment about point A, and this is negative 82.5 Newton meter. Okay, moment kan. So why this is negative? Okay, that means this direction, the moment A ni, yang kita assume the counterclockwise is positive, is wrong. The direction should be in this direction lah. Okay, clockwise. Okay, so that's why we get the value is negative. So it's not wrong, just that the assumed direction of MA is wrong, as mentioned here, and it should be opposite lah, should be in clockwise direction. Okay, so this is solve your first question. They ask you to find the bending moment, determine the bending moment. Okay, next they also ask you to find the required length of the horizontal section that will make the moment at point A is 0. Okay, they ask you to find the length to make sure to make the moment at point A ni 0. Okay, to get that, to find the length of that, you still using the same equation, just that the MA now is 0. Okay, because they ask you, they said the moment at point A is 0, so that will be 0. Okay, and then sama R1 times W minus R2 times M dot V2. So you to find the length, okay, you need to change this R in terms of length lah. Okay, you know that they gave you the weight in the question. Okay, 12 kilogram per length kan? Mana soalan dia? This one. They gave you the 12 kilogram per meter length. Okay, so that's why you change this kat sini. The weight of the horizontal pipe is W equal to W over L. Because this give you the weight per meter length kan. So this is 117.7 Newton per meter length. Okay, and you will get W equal to W times L lah. Okay, W besar ni, this W besar will equal to W kecil times L. Okay, they give you the weight per meter length. Okay, so you get your weight for the horizontal pipe in term of L. Okay, you want to replace this W in term of L, and because you want to find the length. Okay, to make sure the moment at point A is 0. Okay, so that's one. Okay, W, and the R1. Okay, R1, this one, R1 ni, this one, this R1. Okay, this R1 is equal to the length of this pipe kan, over 2, correct? So that's why you get 0.5, and this 1 meter, so the length is 1 meter, over 2 is 0.5. So you can change, you need to change this R1 in terms of L over 2. Okay, so R1 ni will be equal to L over 2, and the W will equal to W times L. Okay, so that's why this equation will become changed to this. So R1 L over 2 times W besar, which equal to WL. Okay, so that's why you have this, and this will L over 2 times LW. Okay, so this will give you L squared over 2 times W minus R2 M dot V2. Okay, so to find the L, the length that will make the moment at point A is 0. Okay, this 0 sama dengan ni. So you can dapatlah macam ni. So you take L out. Okay, this L will add outside. Okay, so this will be L squared over 2W sama dengan ni lah. So that's why you get like this. Okay, if you rearrange, you will get 2 times R2 times M dot times V2 over W. When you bring this kat bawah, dapatlah macam ni, and you can find the L. Just set all of this equation lah. Okay, so you have everything, you have all the value for that. For this value, you have your R2 2 meter, M dot, and V2 over W. So this will give you the length in order to make sure the moment at point A is equal to 0. Okay, so this example lah, one example for angular momentum. Alright. Okay, any question or anything? Ada ke ni?
Ada. Tak ada soalan.
Ada soalan Alright, so I hope this explains the angular momentum and its application. Like I said, don't take for granted, even though I said if you look from the past paper, okay, you can access kan from your mana? Boleh access, awak boleh access ke past paper? Can you access past paper on this subject? Anyone knows?
Boleh.
Boleh Okay. I hope you take your time to look go through past paper kan. Biasalah kalau student mesti akan tengok past paper kan. Okay. Normally if you look in the past paper, there's very I'm not sure bila last kali terakhir yang keluar bab angular momentum. Okay. But having said that, okay, who knows this year, okay, can come out. I'm not sure. I'm not the one that make the question. So that's why I said to you, please understand. Okay, please take seriously about this angular momentum. and how to solve this question, right? Maybe in this year they will come out in your final test. Okay. Okay, so we now finish lah everything in chapter 3. If we recap back all the chapter in chapter 3, panjang lama kan kita belajar chapter 3 ni. I think quite for 3 weeks kan. Ada ke 3 weeks? Ada kot so we cover everything in chapter 3. Okay, from the fluid flow, Eulerian and Lagrangian, visualization of fluid flow, continuity equation, Bernoulli equation, linear momentum, and today angular momentum. So this is all your subchapter in chapter 3. Okay. Okay, now because I promised to you that we will do some tutorial on linear momentum as well. Okay, so I put a few questions in this slide. Okay, for linear momentum, and I can show you how to solve this equation, and you can do at your own time. Okay, this question, and I will also add more question lah on Google Classroom. You can find from that our classroom. Okay, so the first question, I think we will do a few, and then we can stop lah. You have your deadline kan for this Thursday? Kan?
Yep.
Okay. So today is Tuesday. Tuesday. So you have 2 more days. So don't forget lah. I know all of you are busy, very busy, a lot of deadlines. So you need to plan accordingly. Okay. So maybe I will show you a few examples and we can finish lah our class for today. Alright, the first one, a part of a piping system used to deliver oil. Alright, they give you the specific gravity 0.86. This can get your rho. To a refinery in Pasir Gudang is shown in figure 1. The reducing pipe band has a 150 mm diameter at section A. This 150 and 100 at section B. Okay, this diameter will give you the A1 and A2 lah Okay, A1 berapa, A2 berapa, just use the pi r squared. Okay, oil flows through the pipe band at section A. So the oil will flow, comes in and band at section A with a velocity of 3.2 meter per second. So this is your V1. Okay, V1 yang masuk, and a pressure of 150 kilopascal. So there is another force term comes in. This will be P1 A1. Okay, masuk in this pipe. Neglecting the elevation difference between section A and B, so this is very important. Okay, they said to you, neglect the difference between point A and point B, even though in the diagram you have some distance kan. Okay, your point B and point A ni ada elevation lah. Okay, the elevation, but they said neglect, so they assume 0 lah. Determine the pressure reading at section B. So they ask you to find P at section B and the resultant force, okay, the FR, okay, to hold the pipe band in place. Okay, so we have learned this before in linear momentum. Okay, so they ask you to find 2 things. One, to find P, the pressure at point B, and the resultant force, the force to hold the pipe band in place. And they give you this picture, X in this direction positive, Y upward and positive. Okay, first thing first, because they gave you the area of both pipes, so from that and they give you the velocity, okay, the V1 3.2. So from that you can find Okay, first the continuity equation. Okay, I hope you still remember, and that's why this all chapter in all sub chapter is in the same chapter 3, because you will still need to use some of the equation in sub chapter 3 in continuity equation and Bernoulli equation to solve the question. So first you know that continuity equation Q1 over sama dengan Q2 kan, and this is A1 V1 equal to A2 V2. So you have A1 and A2. So A1 is pi times 150 bahagi 2 berapa? Setengah bagi 2 75. Okay, divide by 1000. Okay, this will give you 0. Aduh, terpadam pula. Sekejap saya ulang balik. Okay, so first your continuity equation. Okay, Q1 dengan Q2. Okay, A1 V1 equal to A2 V2. So you have A1. So A1 sama dengan pi times 0.075 square. Okay, 150 mm ni millimeter, don't forget you need to use in meter. And A2 equal to pi times 0.05 square. So 100 mm divided by 2, 50 mm divided by 1000. So this is your A2, and you have your V1 yang masuk ni V1, and you have your, this is P1A1. Okay, and you have V2 outside, and P2A2. P2A2 will act this way. P2A2. Okay, so so you can find your V2 because you have V1. V1 is give to you 3.2 here, and the V is not constant because you know the area is not the same. So you need to find your V2. So V2 equal to A1, okay, pi times 0.075 squared over A2 pi times 0.05 squared times V1, which is 3.2. Okay, nantikan ni. So what is the V2? Can someone calculate this? 0.075 squared over 0.05 squared times 3.2. What's the value for V2?
7.2.
7.2 so 7.2 meter per second. Okay, next, because they ask you to find the P, the pressure at section B. So this, to find that, you need to use what equation? Can someone guess how to find the pressure? Remember what equation that you use to find the pressure? Anyone?
Bernoulli equation.
Yes, correct. So it's Bernoulli equation. Okay, I hope you remember. What's the equation again? Siapa ingat? P1
over rho G
plus
Z1
Okay, good. Plus apa?
V1 square over 2G.
Yes. And baru je ni kan, baru je belajar ni kan. Sama dengan
P2 over rho
G
plus Z2 plus V2 square over 2G.
Okay, so they will ask you to find P2 lah P at point pressure at point B Okay, I mentioned earlier, this is very crucial. Neglecting the elevation difference means that Z1 and Z2 you can cancel out lah. Okay, because they assume in the same elevation, even though in the picture it's not the same. Maybe because the difference not too significant lah. Maybe because this height is very small, so that's why they ask you to just neglect this elevation. Okay, so you can arrange your equation. You want to find P2, so P2 over rho G will equal to V1 squared minus V2 squared over 2G and minus plus P1 over rho G. Okay, so this is your equation, and you can simplify this. I write here. Okay, to get P2, so P2 equal P1 rho G cancel out, plus V1 squared minus V2 squared over 2, and this is times rho. Okay, 10. So P1 equal to P1 for this one 150 kilopascal. Okay, so just put back 150. Remember this is kilopascal, so you need to times 1000 lah. Okay, tambah V1 squared. Berapa V1? V1 is mana V1? 3.2 3.2 squared minus V2 squared. So your V2 is here, 7.2 squared, divide by 2 times rho of the oil. Okay, so they give you the specific gravity, so this is times 860. Okay, berapa nilai P2? Can someone calculate?
132
132
112
112 unit PA Pascal. So this solve your first question 132 112. Okay, and next one they ask you to find the resultant force. Okay, this is where your linear equation linear momentum equation comes in. So this is your first answer, correct? Okay, next, remember your linear momentum equation. Okay, so if you take x, this direction is positive. Okay, for fx, this will be equal to rho times q times v2x minus v1x. Okay, remember you need to draw your FBD kan when we learn this. Okay, because you have this angle, so your V2, this is your V2 kan. So you have another two component, one in x direction, so this is your theta lah, this is your theta. So this will be equal to V2 cos theta. Okay, and you have your vertical component, so this will be V2 sin theta. Okay, so remember to label this component, so that when you put in your equation, you know your nilai, your whether it's minus or positive, so you need to know this. And you have one kat sini juga, one yang V1 masuk, and you have P1A1, okay, in that direction, and you also have P2A2 so I draw here because dah penuh kat sini, So let's say this your pipe. Okay, you have your P2A2 against that. Okay, and this is zero lah actually. P2A2 ni zero je sebab this is released to the atmosphere. But just to label your component. So this is one going down, this is one going to the left. Okay, boleh faham ni? So you need to label your P2 as well. Okay, you have find your P2, the pressure point at here. This 132.1. So this going down is P2A2 sin theta, and in that direction, so this will be P2A2 cos theta. Okay, because you have this angle. Remember this angle, so you have this direction lah. Okay, boleh faham ni? Any question about this? Tak ada?
Tak ada, saya tanya.
Okay, then you can write your linear momentum equation. Add everything that you have labeled. Okay, first, when you take x direction, they gave you already x direction in that direction, positive, and y upward positive. So you have P1A1. Okay, write everything that you have labeled, P1A1, and you have this the resultant force in x. Okay, the Rx. Okay, and then you have the P2A2 cos theta in opposite direction. Okay, this will give minus lah. Okay, P2A2 cos theta. Okay, this will equal to, tak ada lagi kan, dah habis kan, P1 dah habis, dah ambil dia Rx dah ambil, and P2A2 pun dah, and so in this all in your x direction lah. Okay, so this will be equal to rho times q times, so v2x, okay, the velocity at point 2 in x direction, this one, okay, v2 cos theta, and because it move in opposite in the same direction with your x, so you just copy everything lah, v2 cos theta. Okay, minus v1x, v1 in x direction, also in the same direction with your reference point, so you just minus v1 lah. Okay, no tak ada simbol lain lagi kan, so just minus v1. Okay, so this all your linear momentum equation, and then you need rearrange because you want to find Rx kan. Okay, because they ask you to find the resultant force, you need to find Rx and Ry lah. Okay, and summation of this will give you the resultant force. Okay, so Rx, okay, because it's too long I will write here, Rx will equal to rho times q times v2 cos theta minus v1, okay, and plus P2A2 cos theta minus P1A1. This is your equation to find Rx, and you can substitute all this value. Okay, rho, you have your rho 860, okay, times q. So where is your q? Mana q kat sini? Apa nilai q? You need to find kan? How to find q?
AV.
AV, okay, just take another section because they're the same. So if you take V1 3.2 times A1 lah, A1 pi times berapa tadi, 0. Tadi tulis dah 0.075 square. This is your Q lah. Berapa nilai Q ni? 3.2 times pi times 0.075 squared.
0.057.
0.057 meter cube per second. Okay, so this is your Q. I hope you calculate right lah. I just follow your value. Okay, so put back your value 0.057. Okay, times V2. V2 berapa tadi? V2 7.2. 7.2 cos theta dia bagi sini 30 minus V1. V1 is 3.2. Okay, plus P2. So you have your P2 which is 132,112. Okay, 132,112 times A2. A2 berapa? A2 pi times 0.05. Pi times 0.05 squared. Okay, cos 30 minus P1. P1 tadi 150,000. 50 times 1000 times A1. A1 pi times A1 0.075 squared. 0.075 squared. Panjang So can someone calculate this? Ni darab ni tambah ni darab ni tolak ni darab ni. Saya dah letak dah value semua. Berapa nilai Rx? Berapa nilai? Jangan bagi masa sikit. Dapat? Berapa value Rx?
Dapat negatif.
Apa-apa?
Dapat negatif.
Dapat negatif.
Dapat negatif. Berapa? Tak apalah. Cakap je lah negatif pun.
Negatif 1603.34.
1603.34.
0.34.
0.34 lah unit. Apa unit dia? Lupa unit. Ni apa ni? Semua ni
Newton.
Newton. You find the force kan resultant force. Okay, this is force in x direction lah. Okay, why is negative? Apa masalah negatif? So what does this tells you?
Direction.
Yes, and apa maksudnya apa? Apa maksud what you can tell me about this? This is direction. Okay. Arah apa?
Ke kiri.
Ke kiri. Betul lah. Maksudnya can we assume this x direction to right kan? Positive. So when you calculate, you assume that your Rx, your Rx ni ke kanan. Okay, the direction is ke kanan. Okay, when you calculate everything and you get negative, that means your assumption here is wrong and it should be the answer ni dah betul dah. Or you can put your answer 1603.3. I think that's in the notes, and you put your direction to the left. Dia dalam notes macam ni kan. Maksudnya your resultant force in x direction should act against lah. Macam ni you should to the left, not to the right. Okay, so don't worry about negative. Okay, if you get negative, then that's a negative lah. Just a direction je yang berubah. The direction should be to the left. Okay, as I put here. Okay, itu tak habis lagi, itu baru resultant force in x direction kan. You need to do this equation in y direction, and it shows here upward is positive. Okay, so F summation of F in y. Okay, rho Q, okay, times V to y tolak V1y. Okay, so in y direction, what do you have? So you don't have P1 A1, you have Ry. Okay, Ry. Okay, and you have this kan P2 A2 sin theta, and it acting downwards against your reference point. Okay, this means you will minus P2 A2 sin theta. Okay, this equal to rho Q. Okay, rho Q V to y. So this is your V to y upwards, V2 sin theta. So it's the same direction with your reference. So V2 sin theta minus V1y. There's no V1y, so this is 0. Okay, so you can find your Ry. So Ry will equal to rho Q times V2 sin theta plus P2A2 sin theta. Okay, berapa nilai? Tolong kira. Just put back lah everything. Okay, you have your rho 860. Saya malah tulis panjang tak ada. Ada A semua ni kan. Okay, 860 times Q 0.057 times V2 7.2 sin 30 tambah P2, you have calculate your P2 tadi, berapa P2? 132112 times A2 pi times 0.05 squared sin 30. Berapa nilai Ry? Dapat jawapan Ry?
Dapat 693.22.
693.2. So is a positive, so that means your assumption ke atas ni betul lah. So your Ry akan bertindak ke atas. Okay, so you get your Rx and you get your Ry. To get the resultant force, what you need to do is just Add, kat mana tulis Luang dah soalan lain dah. I just write it here kat sini So resultant force sama dengan square root of both of them 1603.3 squared plus 693.2 squared. Berapa nilai? Sama tak dengan ni? 1748. Ataupun lebih kurang lah nilai dia.
Dapat sir.
Dapat So your FR is 1748.2. Okay. And they did not ask you to find the angle. Okay, just resultant force. If they ask you to find the angle, just inverse tangent kan. Inverse tangent Fy over Fx Fy ni awal lah sama don't confuse just I write it as R resultant force in Y and Rx resultant force in S. Okay, Ry over Rx lah if they ask you. In this case they don't ask you Okay, so panjang lah jalan kerja dia. Okay, it's quite long. And that's why this soalan markah dia 12 12 per 12. Banyak kan markah dia Okay, any question about this? Ada soalan?
Tak ada sir.
Okay, don't afraid, just ask if you have a question Okay, the second one. Second example. Alright, water in the nozzle is pointed to the wood block. So there you have wood block showing figure. The inner diameter of the inlet pipe is D1, 0.3 meter, and 0.15 at the outlet. So the area is not the same. The nozzle discharge water into the atmosphere. So dia masuk, dia keluar at point 2 and strikes the wood block at point 3. So you have 3 point, 1, 2 and 3. The total weight of nozzle and water is negligible, so you don't have the W of this nozzle and water. Determine the resultant force. Again, find your FR. Okay, exerted at the elbow. Okay, this elbow. It asks you to find the FR acting at this elbow. And force needed to prevent the wood block from moving horizontally due to the water stream. So another force kat sini yang akan bertindak macam ni in order to make sure this wood block is not moving. Okay, so two things lah, two force that you need to find. So given P1 1.5 kilopascal and V1 1.524. Okay, easy. Okay, they give you everything. So first because you have A1 your D1 D2 ni, straight away you can find your A1. Okay, A1 pi times 0.15 squared, and A2 will equal to pi times 0.15 bagi 2 berapa? So 7.5 kan, 0.075 75 squared. Okay, and you have V1, so that you can find V2 from continuity equation. Okay, from continuity equation, okay, V2 will equal to A1, so pi times 0.15 squared over A2 pi times 0.075 squared times V1, which is 1.524. So what is the value for V2? Potong ni. Berapa nilai V2? 0.15 squared over 0.075 squared times 1.524. Berapa nilai V2?
$6.096.
96. Okay, meter per second. And you have V and you have A, that means you can find Q kan. Okay, find Q. Berapa Q? A times V. Just take any A lah, any A or any apa, any point lah, point 1 or point 2. Okay, kalau A1, A1 lah, and dah V1 lah. Kalau ambil kat point 2, A2 dah V2. So berapa Q? A times V. Berapa?
Zero point 108.
0.108 meter cube per second. Don't forget your unit. Okay, so you have your V2 and Q. Alright, settle. Not yet baru part tu. Okay, now you want to find the FR yang dari point 1 and 2 ni lah. So first solve this one apa part. Okay, yang dulu. Okay, so point 1 and 2 lah. Okay, you need to label everything again in your FBD. So this is V1 masuk, and you have P1 A1 as well. P1 A1. Okay, because they give you the P1. And you have V2 yang keluar, V2 keluar, and also you have P2A2 yang keluar. Okay, this is said is discharge water into the atmosphere. Okay, so this P2A2 will be 0 lah actually. It will equal to 0, and so you don't need to apa, dia akan keluar macam ni, P2A2, but it is 0. Okay, so you get 1.1 and 0.2, and they give here X to the right, Y upwards. So positive to the right as your reference. Summation in Fx equal to rho times Q times V2x times V1x. Okay, and in x direction, okay, you only have the Rx, okay, the one that you want to find. Okay, and plus P2A2, but this is 0. Okay, P2A2, this is eventually 0 lah, equal to rho Q. V2x is V2 and in same direction. Okay, V2. V1x is 0. Okay, there's no component in V1x, so just V2 lah. Okay, so your Rx equal to rho of the water 1000 times Q. You have found your Q 0.108 times V2. V2 is 6.069. Okay, what is the value for resultant force in x direction? 1000 darab ni, 108 darab ni. Berapa nilai dia?
Uh, 658.37.
658 point
37.
Take as 0.4 lah, senang. Newton don't forget your unit. So that means the direction ni betul lah. Your estimate apa into the right is right, because you get positive value but that's only Rx. You need to find your Ry. Okay, going upward, positive Fy equal to rho Q times V2y minus V1y. Okay, and upward, so you have P1A1 ni go upwards so P1A1 in the same direction, plus, and you have your ry, the one that you want to find. Okay, that's all. Okay, this will equal to the row q times v to y is apa, v to y kosong lah kan, tak ada v to y, and v1y, this one v1 lah. Okay, minus v1. So you get your ry will equal to rho times q times minus v1. Okay, and just put minus here. Okay, minus p1a1. So put back the value inside. So minus 1000, the row of water, times q 0.108 times v1 berapa ni? v1 1.524. Okay, minus p1 is 1.5 times 1000 so they give you in kilopascal. Don't forget this. Okay, don't do silly mistake. Okay, times a1 is pi times 0.15 squared. Okay, can someone calculate that? Berapa nilai resultant force in y direction?
Negatif 270.6.
Negatif 270.6 Newton. So again, you get negative. Don't worry, it's not wrong. Just that your direction upwards ni, you assume upward positive is wrong. The ry should acting downwards lah. Or you can write 206 Newton and acting downwards. Macam ni. Okay, so they ask you to find resultant force. Tak habis lagi so you need to write it here. Okay, your FR equal to set of apa tadi? Mana yang X? Oh ni 658.4 square plus 270.6 square. Okay, did you this sama tak dengan ni?
Sama je.
Sama 2711.8 Newton. So this is your final answer lah. Resultant force exerted at the elbow kat sini. Elbow ni, part ni Okay, so that's settled for part 1. And they also ask you to find force needed to prevent the wood block. Yang force yang ni. Ada force yang ni. They ask you to find this one as well. So this is involving this ni lah, akan involve this section part 2 and 3. Okay, 2 and 3. Okay, and you have your V2 keluar, and you have your P2A2 which is 0. Okay, and you have V3 after ada V3 yang masuk kena kat sini, but this kosong lah juga. Okay, and you have dah sudah. Okay, then you write your linear momentum equation in x direction. Okay, take to the right is positive. Okay, is equal to rho times q times v3x. Okay, yang ni yang kena ni tolak v2x. Okay, so that's why I label v3 because you have to component of velocity V3 and V2. Okay, in x direction, so you itu ni kosong. Okay, it's only have x lah, yang ada rx je. Okay, so you have your rx. Okay, and this will equal to rho times q v3x 0 v2, so you have v2x. Okay, so this will be only minus v2x. Okay, so put back your value 1000 times q, q berapa? 0.108 minus, I put minus in front, times v2. V2 is v2, mana v2? Oh ni 6.096 berapa nilai ni?
Negative 658
658.4
.4.
meter. Okay, so it is negative. Okay, that means that when I take positive to the right, so this is wrong. So your rx, okay, should be in the opposite direction. Macam ni lah, patutnya macam ni lah patutnya. Okay, this is the resultant force in x direction that will hold this block from moving. So logik lah, dia akan bertindak macam ni kan. Kalau dia bertindak ke sana, dia akan bergerak lah kan. So that's why your rx is 658.4 this direction. Okay, and if you look this value, this is just the same as your value when you find this one. Okay, kalau orang tu pandai, orang tak payah kira pun sebenarnya ni. Sebab dia dah mesti sama dengan ni kan, yang keluar kan dia RS yang keluar ke sana. Okay, awak kira ni ke sana kan, 658.4, and this force should ada force yang lawan dia supaya blok ni tak bergerak kan. So this value should be the same lah. Okay, 658.4 in to the right or to the left should be the same, so that the wood block is not moving, to prevent the wood block from moving. Okay, so you can, if you just write the answer for this just the same like ni, you put dah betul dah, so it means that you understand lah. Okay, alright, ada soalan? Baru 2 dah 11.30. Any question? Tak ada? Okay, I take that.
So, kalau yang RX tadi just tulis jawapan aja, tak ada jalan pengiraan, boleh dikira.
Maksudnya yang nombor 2 ni? Boleh lah. Sebab that means you understand the value for this must be the same. But you cannot just show from here. Ini awak kira untuk dapat yang ni kan. So you just need write again lah the fx in to prevent this moving sama dengan 68 je lah, equal to this. Faham?
Okay, faham.
Okay, you still need to write the answer. Don't just leave it there. I will not know whether you understand this value is the same with this Rx to prevent this wood block. That's why you need to still need to write your answer. So the Fr to prevent the block is equal to whatever lah. Okay, this. Okay, again, and this is 12 mark. Ini semua past paper je ni. I take from past paper. So if you do from your past paper, you will master lah in this chapter. Can you ask anything else? Any more question? Tak ada?
No, sir.
Okay. Next, I think the last one kot and then maybe you can try the other ni at your own time lah. Okay, if there is no answer, just If you do it and you want to check, just text me or you can ask me, email me, and can I give you the answer. I think we don't have more much time. Last one. Okay, this one. Water flow at rate 65 liter per minute. So this is your Q. Okay, just change that in meter cube per second. Through fully open tap is shown here. The inner diameter of the inner pipe is 3 cm. Okay, and 2 cm at the outlet. So you have your A1 berapa and your A2 berapa. Okay, from this diameter, the tap discharge water into the atmosphere. Okay, there goes to atmosphere. The elevation difference between the center of the outlet and the inlet is 5 cm. Okay, so there you have your Z. Okay, between point A and point B, point 1 and point 2. So you have your elevation difference is 5 cm. The total weight of tap and water is negligible. Okay, there's no W. Determine the gauge pressure. Okay, gauge pressure at the center of the inlet. Okay, kat sini. So P1, and the anchoring force Fx and Fy needed to hold the tap in place. Okay, so they ask you to find P1 and Fx and Fy lah, or Rx and Ry in my calculation. Okay, just the same. Okay, first you need to change Q 65 liter per minute in term of meter cube per second. How you change that? So 1 minute equal to 60 second, and 1 liter equal to 0.001 meter cube. Betul kan? Understand this? Boleh faham ni? How you change this? Okay, that's why you can cancel out the minute and cancel out the liter. So this will give you 65. Berapa nilai dia? Times 0.001 bahagi 60. Apa nilai in meter cube per second?
1.08
times
10 power of negative 3.
Times 10 power of negative 3 meter cube per second. Okay, so make sure you know how to convert. Okay, if not, okay, it will affect lah everything. You cannot solve everything. Because this Q you will use it in your calculation kan after this kan. Okay, so A1 sama dengan pi times apa 0.015 squared. Okay, and A2 pi times 0.01 squared. Okay, just using your diameter, and you can find your V kan. Okay, you have your Q and you have your A, so you get your V1 dengan 1.08 times 10 to the power of minus 3 divided by A1 pi times 0.015 squared, and you get your V2. Okay, 1.08 times 10 to the power minus 3 divided by A2 pi 0.01 squared. Okay, you get your V1 and V2. Okay, why you need to find that? Because you want to find P1 kan. So what next equation yang kita akan guna? Second step. So ni first lah, ni first step. Apa second? What equation we use to find P?
Bernoulli equation.
Bernoulli equation. Okay, Bernoulli equation. Okay, P1 over rho G plus Z1 plus V1 squared over 2G equal to P2 over rho G plus Z2 plus V2 squared over 2G. Okay, so you have your V2, so you have your V1, and you have your You want to find P1 kan? And what is the P2? Apa nilai P2? What's the value for P2? Siapa boleh teka? P2 berapa P2? Anyone? Hello?
Zero.
Kenapa takut? Cakap kuat sikit. Apa?
Zero.
Zero lah. Zero je. Salah apa? Sebab dia adalah into the atmosphere kan. Okay, so P2 is 0. Okay, there's no pressure at point 2. So you can cancel out. Z1 and Z2, which one is 0? Huh?
Z1.
Huh?
Z1.
Z1, are you sure? Ni Z1 kan? Kat ni Z1. And this is Z2. Right, depends lah where is your reference point Okay, betul lah. Mungkin awak ambil Z1 as reference point and Z2 will be minus 5 lah. Okay, so this is Z1 and the difference is 5 cm. Okay, if your reference point is Z2, so this is 0, this will be 5 lah. Betul? Betul tak? Faham tak ni?
Lepas tu.
Okay, so if you take Z1 0, maksudnya your Z2 is minus 5. If you take Z2 is 0, then your Z1 is 5 lah. So either one lah. So just Z1 minus Z2 is 5. Okay, so they give you the difference kan ni. Okay, difference between this 5. Okay, I take Z2 is my reference point. I always take the bottom as your reference. So this will be 0. So this will be 5 Z1. So you have everything. You have Z1, you have V1, you have V2. So you can find your P1 lah. Okay, P1 equal to V2 squared minus V1 squared. Okay, over 2. Okay, times rho minus rho times G times Z1. Berapa nilai dia? Just put everything. V2 berapa, V1 berapa, rho water 1000, rho water 1000, G lah constant, and Z1 is 5 cm. So Z1 will be in meter lah, 0.05 meter. Berapa nilai P1? Dapat tak sama dengan value ni? 4290.3. Dapat? Kalau ni jawapan ni betul lah. I just put here. Ada dah dapat kira? Anyone get it?
Tak dapat tu.
Tak dapat. V1 berapa nilai ni? Berapa nilai V1? 1.08 bagi ni. Berapa nilai V1 awak yang awak guna? Hah? Berapa?
V1 dapat 1.53.
Okey. V2
V2 dapat 3.44.
3.44. Okey. And you put back lah 3.44 squared tolak 1.53 squared over 2 darab dengan row. Row is 1000. Lepas tu tolak row 1000 darab 9.81 darab 0.05. Tak dapat ni dapat apa? 3.44 square tolak 1.53 square divide by 2 times 1000 minus 1000 darab 9.81
Dapat kurang sikit sir.
Berapa awak dapat?
Dapat 255.85.
255.
Dapat 255.
Oh, okay. So maybe the difference is kat sini lah kot V tu mungkin dia ambil lain kot not sure but tambah. Okay, you get 42 apa? 4255.
42
betul lah ni. Point berapa? Point 8.
Yes, point 8.
Point 8. So this sama lah So maybe they take 1.53 something ke 3.44 ke Okay, sama je don't worry about that. Okay, just decimal places maybe kat Q pun boleh berbeza juga kat sini so don't worry about that. Okay, mak lagi 10 minit lagi FY then you find alamat tak ruang kat sini fx. Okay, this one positive. Fx equal to rho q v2x plus v1x. Okay, and you have your force in x, so you have P1A1 masuk you need to label this so that you can see. Okay, P1A1 plus your resultant force at x. Okay, and you have apa lagi yang ada? Tak ada ni P2A2 ni 0 P2A2 0, so you don't have this P2 cos theta or P sin. You have but it's 0, so you don't just ignore that. This will be equal to rho q times v2x. Okay, you have v2 out ni, so v2x will be v2 cos theta lah right, betul? So v2 cos theta minus v1x is v1. Okay, horizontal. Okay, so you can find your rx. Just put back lah the value PQ V2 ni semua V2 cos theta minus V1 minus P1A1. Ni Q Q. Okay, and if you put all this value rho 1000 times Q times V2 and you have your V2 3.44 cos theta 80 minus 1.53 V1 minus, okay, after you times this and minus P1 is apa ni P1 P1 ni lah, dah kira dah ni, betul lah. Okay, so your P1 4255.8 times A1. pi times 0.015 squared. Okay, if you calculate this, you should get this value lah, 4.04 Newton, and negative 4.04 Newton.
Dapat tu.
Dapat. Okay, good. So this negative means the direction is wrong, and it should be to the left. So you can write 4.04 in bracket the direction to the left. Okay, and RY pun samalah, buat benda yang sama. Okay, Fy, okay, go up is positive. So this is rho Q times V2Y tolak V1Y. Okay, you have V2Y. Okay, first in term of force, so you only have so this no Y and this also no Y. So only Ry lah tinggal. Okay, and this will be equal to rho Q. V2Y is V2 sin theta lah, V2 sin theta. Okay, in opposite direction, so this will be minus lah, minus V2 sin theta. And V1Y is 0, so there's no component in V1Y. So your Ry is rho times Q times V2 sin theta minus rho 1000 times Q times V2 3.44 sin theta. Dapat tak negative 3.68?
Dapat tu.
Dapat. Okay, good. So your Ry negative sama juga, maksudnya dia ke bawah lah. Anchoring force tu apa? In y direction should acting downwards, not upward. So settle, dapatlah semua jawapan for gauge apa? The gauge pressure, inlet, and also your anchoring force Fx and also Fy. Okay. So F1 jangan apa? F1 ni Fy ni sama dengan Rs lah. Maybe you apa? Kalau kau tak confuse je, sama je. F1 ni I use Rs and Ry Fy lah. Okay, R ni force lah, resultant force. Okay, so dapatlah 12 markah lagi. Banyak kan markah. Okay, any question before we end? Dah 12:45 dah. I don't think I will do another example. Okay, you can try this on your own. Okay, and this one, and this one, this one, this one. Okay, just to master this chapter lah. Okay, and you can ask me, you can text me, or you can email me to ask for the answer. Okay, anything? Any question?
No sir.
Tak ada yang lain-lain?
No, sir.
Alright, so
Thank you, sir.
that's all for today, I think. Thank you